All right, we're now recording. And let me get back to my screen. Did I lose everybody?
No, sir.
Okay. We go to home, return to meeting. That'll do it. Okay. Now, still got Jermanuel waiting, so let me get him in. So we're up to 11 students back. We started with more than that. Seems like it was 16 or so. Hopefully we'll get them back. Let me see if I can share a screen here. There's Blackboard. That's where we left off. Okay. Now, I think I know why. Okay. Why this is up here out of where I want it to be. But let me move it down here. Okay. I'll move this over here so it's kind of out of the way. Okay. Hopefully we'll get the people back. If you see anyone trying to get back in, let me know. Let me let you know when I shut down my computer, guess what? It always happens. They decided they wanted to update something and wouldn't let me shut off anything, so I had to wait for it to update. And then as soon as I started back again, everything took, I'd say 10 times longer. Everything I'd hit on, it would say resolving host and just sit there. Whereas earlier today, it would come up just about instantaneous. So I don't know. Every time they do an update, somehow it seems like it messes up. So let's go back to the syllabus, if I can get there. All right. We've been here before, so I'm going to click on syllabus and then click on the three dots here, and that should open up my syllabus. It says, okay, download original file, open it. Okay. All right. I don't think I'm going to need to edit, but I'll go and sort of move this out of the way here. Okay. Were there any questions from before that you had? Oh, screen sharing is paused. Let me get it back. Okay. Can you see the syllabus now?
Yes.
All right, we're back where we were 15, 20 minutes ago. Sorry about that. Okay. Let's move on through this. Instructor contact. I'm in no office. I'm at home. No office phone, so don't have that. I do have email. So if you need to communicate with me, email is one way, and several of you have done that already. Even today, I was in communication with a few people earlier. And I don't know who's back now or not. I don't even remember. I know there were two people who had shared emails with me. Are both of you here now?
Yes.
Okay, good. Okay, so we are in communications. Okay, my office hours. And I'm going to show you my locator card a little bit later that'll have a lot more detail than this. But here's what they are. Mondays and Wednesdays, 8 to 11:30. I'm here in the office. It's actually a bedroom, okay, from 8 to 11:30, and on Mondays and Wednesdays. And then on Tuesdays and Thursdays, I've got an 8:30 class and a 11:30 or something like that class, 11 o'clock class. So that's I'm in the office from 8 to 8:30, and then that class is over with at 1:15. So I'm always in the office, but I'm available in the office from 1:15 to 5. That's Tuesday and Thursday. Okay. The college is closed on Fridays. We're not doing any business on Friday. I will probably be checking emails and things like that, but it won't be as often as during the regular week. Okay. So let's move on down to the course description. Any questions so far? Okay. This is the second of 3 courses in the basic calculus sequence. Topics includes vectors in the plane and space, lines in the and planes in space, applications of integration such as volume, arc length, work, and average value, techniques of integration, infinite series, polar coordinates, and parametric equations. Now that's a mouthful, and that's also a term full. In fact, seldom can I get a really good coverage of all that material in one term. But what makes it worse is, and Jonah and Jemanuel and Houston and Cal, if he were here, some of the others, I don't believe Angelica's here yet either, but they were in my class this past spring, and that was the interrupted term. That's when we left campus, started doing virtual classes in March, right in the middle of the term. It was shortly after midterm, and that took a while to get going well. Then my computer that I brought from campus died, and we ordered some parts for it to bring it back to life, we hoped. The FedEx delivered them to some other address, or they threw them away or something. They claimed they delivered, but they never came here. So we had to reorder. They came by UPS, and they got here a day early, in fact. But it was still a week and a half I lost there. I still tried to teach, but it was really poor. Then, sometime after that, we had a really bad storm on a Sunday, and things were okay. But middle of my class on Monday morning, the internet went out, and it stayed out for more than 2 days. It's kind of hard to do virtual classes with no internet. Now, when my wife had a hotspot and we tried to share that, and we get such a terrible signal where we are, all a hotspot does is amplify the signal, but I had such a terrible signal to begin with, we had a terrible time teaching that way. And here's Houston back. Let me get Houston back in the course. Hold on, here we go. Okay, Houston's back, or he will be soon. Okay, and then all the other things were happening too. I was operating first on my wife's iPad, and that wasn't very handy, but we had a few classes that way. And then ultimately, she got a computer, an old computer we had here, updated, upgraded, and I could do some of the stuff on that new computer, not all. The school promised me they were going to get me a computer with everything I needed on it. When they finally delivered it, it was locked and I couldn't use it. Okay, so I went back to using the old computer without everything on it, and it really slowed down the entire process. So the bottom line of this long, sad story is we did not finish chapter 5. We didn't even get started in chapter 5, which was the integration chapter. So sorry about for y'all folks that are from other schools, you probably already had the first part of this course, the integration part, antiderivatives and that type of stuff. Am I right? You probably had it in your Cal 1 course.
Yes.
Yeah, well, unfortunately, our students didn't. So we're going to start with chapter 5 and try to go through it as quickly as I can. But as you see, things don't move too quickly here. I don't know why the Screencast-O-Matic screwed up today, but it did. But anyway, we're going to have to start with chapter 5, not chapter 7. Chapter 6 is differential equations. We're not going to do that anyway. Okay, so anyway, those are the topics we're covering, plus antiderivatives and integration. Okay, prerequisites, it has a prerequisite of blah, 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 basically Cal 1. Hopefully you've all met that. Okay, the textbook, I'll show you what it looks like. It's this big old thing. And this is how I'm going to have to operate, showing you things on the camera. The previous computer, the one that died twice, by the way, we did get a new part, and they worked for about a week, and then they died again. So the computer was just shot. It was a computer that was a tablet PC, meaning it had an ionizing pen. I could write on the screen, work out problems on the screen. It was fantastic for teaching. I used it in class, and I used it as a virtual class, but it died. And they didn't have any more of those. It was an old computer, so they provided me with this one. It's a very nice computer, but it doesn't have that capability of writing on the screen. Okay. Zoom does have a whiteboard, but you can either type on it or draw on it. And my typing's slow and my drawing's terrible. So I'll use that if we have to, but otherwise I'm going to be working problems, and then when I work a problem, I'll hold it up and show you what I've done. That's a trig problem or something like that. And that's how we're going to be sharing. So I suggest that you have pencil and paper in hand. I will be using ink. I don't like to do math in ink. I make too many mistakes, but the ink shows up better on the camera. So here's the bad news of that. I don't know if the camera records or not. Did any of you in my class before, when I was doing the same technique, did you ever go and look at the YouTube videos to see if the camera shot showed up on the YouTube videos? Jemanuel or Houston or Jonah? Any of you? Yeah, I said Jemanuel.
Yeah.
Did the camera show up on those YouTube videos?
I think some of them they did, some of them they didn't.
Yeah, I think it's a really small picture, even if it does show up. So I don't know if you'll be able to read it, but I'm going to continue doing that. I just don't know if it'll be on this. So notice remember, I'm recording this. What I do with it after class is I upload this to YouTube video. And then sometime well after class, when it loads onto YouTube, I'll move it into a folder, and we'll talk about that in just a few minutes when we get back to the syllabus. Okay, so there's the textbook, Calculus Early Transcendental Functions. Can you see my cursor here when I move it around? The arrow? Okay. It's a 7th edition book, 2019 copyright, so it should be good for a little bit. Now, many of you are coming from another campus. You probably don't use this text. If you have a calculus text, then certainly use it. Just find the chapters that are characteristic or corresponding to this. The chapter on integration, antiderivative, something like that, that's where we'll be beginning. If, however, you do want to use the text, Cengage Unlimited, it's a Cengage book. For $119, you get an ebook and WebAssign and all that kind of stuff that comes with it. That's cheaper than the book is. Now, you might be able to rent the book cheaper. You can work that out. But if you have a book you've already paid for from your home campus, just follow that. The calculus is no different, whatever book you're using, and the testing will just be basic stuff. So don't fret it if you don't have the same text. If you have questions, let me know, and we'll try to work those out. You can hold up your text in front of the camera, and if I can see your camera, then I will tell you what chapter. We'll do the best we can. But if any of you are interested in Cengage Unlimited, here in the syllabus, there's more. It's just like an advertisement. I hate they make us put it in there, but it is. It's $120. If you do want a physical copy with it for something like $10 or so, you can rent a loose leaf text, but you have to be in the other. Actually, they say $8 here, okay? It may have gone up since they put this in the syllabus. All right. Now we get back to our regular syllabus here. All that was advertising. Blackboard, it says all courses must use Blackboard, blah, blah, blah. Okay, let's look over. I'm in Blackboard now. That's where the syllabus is. That's where the handouts are. Now, usually I don't have that many handouts, but that's where they'll be since we're on a virtual campus. The PowerPoint shows are there. I'll show you that in a little bit. Activities. Sometimes the school posts activities, but we aren't having many activities, so that's sort of nonsensical. Assignments. Okay. I'm not going to type up the assignments every day. I think they want me to, but I'm going to give them to you on the YouTube videos. In Screencast-O-Matic, they'll be there. So if you miss a class or miss understanding what to do, go to your YouTube video, and you'll find it there. Okay? Announcements, I don't know of any. Oh, wait. Morgan's trying to get in. Has Morgan been here before? Morgan Huggins. I don't think so. Morgan, are you here? I see your microphone. Are you here, Morgan?
Yes, I'm here.
Okay, what do you go by? Wait, you were here before, weren't you?
Yeah.
Oh, okay. Do you go by Morgan? I forgot to circle your name.
Yes, sir. I go by Morgan.
Okay, got it. All right. I was thinking I hadn't circled your name and I thought you were new to the class, but you've been here before. Sorry, it took me a long time to get the reboot doing. So anyway, that's over with. So y'all let me know if you see anyone else pop up. Okay? So where were we? We're talking about Blackboard announcements. Sometimes the school will put announcements. If I have any, I'll put them out there. Well, the YouTube videos is an announcement before every class. I usually post that invite, the Zoom class invite. I'll post sometime the evening before. Okay. Now I don't like these other sentences, but we don't have time to go over those. They do the wording here. I don't care for them. Okay. Student learning outcomes. This is the normal stuff. Students will apply definite integrals to volumes, arc length work, and that kind of stuff. Just for your information, in our text, if you're using this text, in other texts, they'll have similar names. That would be, in our text, it's Chapter 7, Applications of Integration. Okay? That's applied definite integrals. Okay? We're starting with Chapter 5, which is just integration. Sorry, it'll be a review for the rest of you. Students will use different techniques of integration, such as integration by parts, trigonometric substitutions, partial fractions. That's Chapter 8. In our book, it's entitled Integration Techniques and Improper Integrals. Okay? See, the improper integrals aren't mentioned here in our course description, so I don't think they were anyway. Let's go back. Now that I say that, let me go back and see. I usually don't spend a lot of time on improper integrals, but I introduce you to them. Sorry, this is slow. All that advertisement. Okay. No, it said nothing about improper integrals, but we will cover it just because it's in the chapter, but we won't do a big deal on it. Okay? I'll just go over it quickly. Okay? Now, in my mind, the bulk of this course is right here in these two chapters. Applying integration and techniques of integration. The rest of it is not quite as crucial in my mind. Infinite sequences and series, because we have very little time, we'll probably just do two sections. One on infinite sequences and one on infinite series. I'll go over the rest, introducing them to you, but we're not going to be testing on them. Okay? Then we'll solve parametric equations. Oh, and by the way, going back to the chapters, Chapter 9 is infinite series. It has 10 sections in it. We're not going to cover 10 sections. We'll probably just do the first two, 9.1 and 9.2. Okay? Then, and let me scroll down here. You'll see the same thing is going on here.
Anita, can you mute your mic?
Okay. Thank you for that. I'm sort of hard of hearing, so I don't hear as much as you do. So thank you for piping in. Okay. So Chapter 9, we'll just do a couple of sections in that and see you won't have a test under Chapter 9. But parametric equations is Chapter 10. And Chapter 10, the title is Conics, Parametric Equations, and Polar Coordinates. Okay? We're not going to do conics. Okay? I'll introduce them to you, just go over them quickly. And but we'll do 10.2, plane curves and parametric equations, 10.3, parametric equations and calculus, and I'm trying to remember if, I guess we'll do the polar coordinates. That's 10.4, okay? We're not going to go in gory detail on those, okay? But then 10.5 and 6 we're going to skip. So after we do the 2 sections in Chapter 9 and 3 sections in Chapter 10, that will be your test on Chapters 9 and 10, okay? Then, if there's time, we will do the first 5 sections in Chapter 11, Vectors and the Geometry of Space. The 6th section there is where Cal 3 begins. So that's what we're going to try to cover. We have a shortened term, and I've already lost. Here's Keshav back again. Let me admit him back in, So hopefully he'll be back. So we're up to 15 students. We were at 16, I think. So maybe the two are sharing again. I don't know. All right. So any questions on the content? And I'll apologize ahead of time. We are not probably going to be able to cover all these sections. Like I said, we've got a shortened term already, and we're having to cover chapter 5, which most of you have covered. But here's the other thing. This is our first day of class, right? The Tuesday, Thursday classes already have completed a week of class. I beg them when they do the calendar, I've been in the meetings and begged them, please don't start classes on a Tuesday or a Thursday. Always start either on a Monday or a Wednesday. The reason for that, every term, fall term is Labor Day, winter term or spring term they call it is Martin Luther King Day, and summer term is Memorial Day. You have 3 Monday holidays at the very beginning of every term. So I say, please start the classes either on a Monday or a Wednesday, because shortly into the term, the Monday, Wednesday sections always lose a day. They did it one time and then refused to do it again. I don't know why. They have short memories. They don't listen. I don't know. I explained the reason. They don't care. Administrators don't understand classroom teaching. Okay? So we're a week behind the Monday, Wednesday, Tuesday, Thursday classes already. And guess what happens on the 4th of July? It comes on a Saturday. So they had an option of having Thursday as the holiday or Monday as the holiday. Guess which one they chose? Monday. So we are going to be a week and a half behind the Tuesday, Thursday classes. And not only that, then final exams start not only with Tuesday or Thursday, but on a Wednesday, I think it is, or whatever. But anyway, we don't pick up a day at the end either. So I apologize for that. So let me get on. One other thing here, I want to make sure. Students will research and write on a topic or computer application in calculus. You choose your topic and go with that. That's your writing competency, okay? I'll talk more about that a little bit later. We'll get to that in the Blackboard. So here's how I evaluate and assess you. The research paper is required. It will count as a test score that cannot be dropped. The research paper is not a droppable test. The chapter test will be given after each chapter, or 2 chapters in the case of 9 and 10. Okay, the lowest test score can be dropped, may be dropped, the last exam, and that's not going to be comprehensive. It'll just be the last chapter we cover, whether it's 11, 9, and 10, whatever the last chapter is, that will be your final exam, your last exam. That one cannot be dropped. So don't come at the end of the term, hey, I have A's on all my tests, can I drop the final? No, the last test we have to hang on to and keep for 3 years. I don't know why, but they require us to. So the final exam is not a droppable course, okay? A test. The research paper is not droppable and the final is not droppable, but the lowest test in between can be dropped. Here's how we grade, just as normal. 90s are A's, 80s are B's, 70s are C, and don't go any below that, okay? Stay away from D's and F's. Okay. I think y'all know enough about attendance. Please try to be here every day. If any of you are on financial aid, and I know at least one of the students that emailed me said she was, and guess what? Can't march you here if you're not here. So please be here when you can. Now, and I do record the classes, but they're not as good as being here. Try asking the recording a question. You just can't do it. Or you can, but it won't give you an answer. Here they put in this 3 paragraphs here. Virtual classes require you to attend classes based blah, 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 blah. I'll let you read that. This is something new they added, so please pay attention to that. And this is what you're supposed to have, though we don't have reliable internet access. We have internet access, but it's proved last term not to be all that reliable. I've been through several personal computers. So do that. I don't need a webcam. I have the camera built in my computer, and the audio headset. That's up to you. I don't use a headset. Okay. The testing varies, and basically, I did want to ask this question before we went any further. I should have asked it on the last slide, last page. Do you prefer in-class test or take-home test?
Take home.
What?
Take home.
Oh my goodness, I'm surprised at that. Shocked me. Okay, I'll have to rearrange. No, I was expecting that. Your test will be take-home. I will send them to you. I'll show you where I will once we get back into Blackboard. We're in Blackboard now, but when we get back, I'll show you where the test will show up. Okay? So, I usually say take about a week to do them. That allows you one class period to ask questions if you have questions. It also always gives you a weekend to work on them. If you need more time, you can have it, but please don't have the previous test out when I give the next test. So get them in as soon as you can. Okay, but I give you always a week to do it. Okay, so don't worry about this proctor U and that kind of stuff. Withdrawals. I think all the Lawson students already know all this because you've been in my class before. The other students, if you withdraw, you don't get credit to take back to. So I'm not going to spend much time on that. Makeup work, I find it hard to imagine what makeup work is for take-home tests and take-home research paper, so not too much there. I'll try to start every time right at 11:30, and I'll end when you stop me, okay, because most of the time I'll go over. Please stop me, though, in time, because I have another class starting 5 minutes after this one, so don't let me go over, okay, please. All right. Academic integrity, please have it, okay. Plagiarism, don't do it. Cheating, don't do it, okay? I'm summarizing here, okay? Read this. It is pretty important stuff. I'm not minimizing it. I'm just summarizing it. Professional decorum. Now, this is truly important on a virtual class, okay? If you're sleeping when I'm talking, I'm going to be all over you. How will I know? Okay, okay. If you're in unnecessary traffic in and out of the classroom, we don't have a classroom. Okay, eating or drinking. I brought up snacks because I have 5 minutes between classes. I'm not going to be eating or drinking, but if I need to, I will do a swig of water or whatever. And if you're wearing inappropriate clothing, boy, that gets you in serious trouble. Especially sunglasses. I just can't say. Or hats. Oh, please. If you have a hat on, you lost 15 points towards your final. No, I don't care. Okay, even in class, I don't care. But they have all this as part of the dress code, so that's immaterial. I probably wasted too much time on it. Okay, course concerns. If you think you're not getting what you need out of the class, let me know, and we'll try to speed it up, slow it down, whatever it takes. If you are unsuccessful talking to me, go to the department chair. Oh, that's me. Okay, yeah. We'll handle it, okay? Then go to my boss. He's the associate dean. Then go to his boss. She's the dean. Then go to the vice president. Then go to the president. We will get it taken care of. But if we can get it taken care of at the lowest level possible, let's do so, okay? Now, statement on discrimination and harassment. Let me summarize this too. Do not do it, okay? And I don't even know how you discriminate or harass in a virtual classroom anyway, but if you see or sense or figure any way this is happening, let me know because we don't want it happening, okay? Disabilities. I can't remember if it's one in this class. It seems like it might be, but I have several already forms coming in from the ADA specialist here. If you have a disability that you need some type of accommodation, please let the college know. If you let me know, I'll send you right to Dr. Renee Herndon, virtually of course, who is in charge of this, or Mrs. Janine McCoy-Jones. They are very good, they're professionals at it, and they will take care of you, whatever it takes. Any questions? Here's the college course calendars, taken right off the academic calendar on the website. I didn't put all the dates in that didn't pertain to the course, but here they are. Here's just a couple things you might need to know about. If you are withdrawing from a class and you're on some type of, well, wait, let's go back to this one. If you're withdrawing from school, not the class, if you're having to withdraw from school, you family has suddenly had to move or some other reason, something's come up, you have to withdraw, you get sick, something has come up that you have to withdraw. If you do it before Friday the 12th of June, you'll receive a partial refund. But that's a complete withdrawal from school. Now, if you're withdrawing from a class, okay, that's where the 60% completion date, that's the 30th of June, okay? If you withdraw before that date, you owe whoever you have the financial aid through, FAFSA, Pell Grant, maybe VA, whoever it is, you may owe them money back. After the 60% completion date, after June 30th, sometime into July, if you withdraw then, you don't owe anything back. So just keep that in mind. And unfortunately, Independence Day celebration will be Monday the 6th rather than Thursday the 2nd. Over my objection, okay, but they still did it. Okay, last day to withdraw from class, okay, like we were talking about. Oh, here's Joy back, or at least her phone, okay. So here's, I hope Joy's back here now. So we're back, I think, to the 16 that we had before. That's good to see. Okay, the final exam, this is wrong. I'll have to change this. I think ours is on Wednesday, the 29th of July. I copied this from another class, but that was a Tuesday, Thursday class. So I forgot to change that. So our final exam will be Wednesday, the 29th. Well, actually what I'll do, the final exam, I'll give you the previous Monday actually. I'll give you the exam on Monday and you get it back to me as soon as you can. Grades are due by August 4th, so I'll need that test back before 4th of August. Not on the 4th of August, before the 4th of August. If you can get it back to me that week, the week of the 20, whatever, 8, 29th, 30th, you know, and that, anytime that week, that would be fantastic. Technically, they're due on Wednesday the 29th, but if you get it back to me anytime that week, that would be good. Okay? And or the Monday after that week. Because Tuesday, I have to have grades in. Usually, they want them in by noon. So don't give them to me Monday morning. You know, I don't have time to grade it and get the averages and Blackboard and everything done. All right. Now, the dean wanted us to have an assignment for every class. And I'm supposed to type this up. I'm not going to. I'm telling you now. Here's the assignment. Go back and read the syllabus. See if you have any questions whatsoever. If you do, ask me. Either email me, message me, whatever. Let me know if you have any questions. Once I've answered all your questions, then either type your name here and date and send it back to me. Email it to me as an attachment. Send it to me in Blackboard messages. Somehow get this back to me. That's your assignment for today's class. Okay? So our dean was a former grammar school teacher, so she thinks in terms of grammar school. I apologize for that, but every class I'll say, do one of these and get it back to me, you know, just to fulfill her requirement that we have an assignment every day. Okay. But this is the one for today. Any questions on the syllabus? I can go back up wherever you need me to go. Any questions?
Dr. Fowler.
Yes.
I see that you have like a WebAssign code, right?
Yes.
So that's just for the book, for us to be able to access the book, or?
Okay. That's an excellent question. Okay. You are, I take it, a transient student. Is that right?
I've taken your class before a while ago, but I know you didn't never use WebAssign.
Okay. So you're a Lawson student then, is that right?
Yes, sir.
Okay. Gotcha. Okay. Here's the deal on that. I don't make assignments on WebAssign. And I'll tell you why now, okay? I've tried it before, and I spend more time trying to calm students down, because they've done a problem, and frankly, they've done it perfectly correct. But WebAssign tells them it's the wrong answer. And they get all bent out of shape and think they've done something wrong and try to change their approach and do like this. And then they come to me finally and say, what am I doing wrong? I'll look at it and say, oh, WebAssign just wanted it in a different form. Because WebAssign is a computer program. You feed it in and they only put one correct answer in. You'll see in calculus, there's probably 15 ways to write a correct answer. They're looking for one of them. So I spent more time calming students down who had it right and then changed their minds and changed this, that, and the other, all for nothing. So it turned out to be more of a frustration for me and for the students than I thought it was worth. However, WebAssign has excellent practice problems. They have tutorial help. They have all sorts of these things out there. But to answer your question, the main reason I give it there is so you can access the ebook. If you need a code, they call it a key, campus key or class key or something like that. If you need it, there it is. Okay? If you're not using WebAssign, you don't need the key. But that's way, if you need it for your ebook, if you want to use WebAssign, that's all there. I had them put questions from every chapter, every section that we cover, probably several that we won't cover. They're out there for your viewing pleasure. Okay? So that's why I put it there, so you can access the ebook if you are using the Cengage Unlimited. Okay, I don't know. They change the rules on that all the time, so I just put it out there. If you need it, use it. Did that answer your question? I remembered. I know who you are now.
Yes, sir.
Yeah. Okay, got it. Okay. All right. Any other questions? Good question, by the way. Okay, so I'm going to leave the syllabus. And once I do, you might lose the screen sharing, but I'll pick it back up in a minute. Yes, it has stopped. Hold on. I'll be right back with screen share. Okay. Let me see if I can find what we go to next. Well, no, I don't see it. So I'm going to have to, oh, there it is, right there. Take me just a minute to get back. I'm going to try to get screen sharing back now if I can. That may be it. Yes, can you see the syllabus again? Yay or nay?
I see Blackboard.
You see, yeah, I'm sorry, whatever I called it, Blackboard. We did the syllabus. Let's now go to the locator card. Okay, again, you click on that, but then you come over and click on the dots here. Download the original file. This is slow doing it this way, but I just wanted to illustrate to you, demonstrate to you how it worked. Okay, now it may lose it again. Yep. New share, locator card. Okay, can you see my locator card?
Yes.
Okay, so there's my name again. It hasn't changed. I have no office phone. There's my email address. It hasn't changed. Department's Mathematics. Let me see if I can get the entire week to show. Yeah, there it is. I'm going to get this out of my way. You probably can't see it, but it's in my way of seeing. Okay. Well, I tried to get it out of the way. Well, it won't get it completely out of the way. All right. As I said before, on Monday, Wednesday mornings, I have office hours. I'm here in the bedroom, the office, from 8 till, it says here 10:30. I usually do grab a little something for lunch somewhere around 10:30, but I'm usually back before 11:30. I'm usually here after 10:30. It doesn't take me that long to eat lunch, but they require us to put down an hour lunch every day, so I did it. Then this class goes from 11:30 until 2:25, and then my physical science class starts at 2:30. It goes until 4:45. Then the physical science lab starts at 4:45, and it goes until 6:15. However, the lab part, we can't do physical labs. Some days we may take the full hour and a half. Other days I just take them to a virtual lab, explain to them how to do it, answer all the questions they have, and then I say, do you want me to stay with you, or do you want to work on your own? They say, let us work on our own. If you have questions, we'll come back. So most days I'll stay in the office, but I may not be in the lab until 6:15. I'll be in the office till 6:15 or later, but I'll be probably not in the lab that late. Okay. Tuesday and Thursday, I have office hours from 8 until 8:30. Then I have a differential equations class from 8:30 until I think it's 10:45, and then linear algebra from 11 until 1:15. Again, they require us to put a lunch down, so I usually go down to grab a bite to eat sometime between 11:15 and 1:15 and 2:15. Usually I'm not down there that long. I usually don't leave right at 1:15, and I'm back before 2:15. Okay. Then I have office hours again from 2:15 until 3. Now, what's the difference in office advising and office hours? Not much. But since we're virtual, we have what they call a virtual advising center. Did any of you use that to get into your courses this summer? Yay or nay?
Yes.
You did. Okay. So you know you go and you sign up for a half-hour slot sometime in the day, whatever day you want to do. Well, in this summer, they require us to have 5 hours of advising hours. So I chose for mine 3 to 5 on Tuesday afternoon. That's 2 hours. 8 to 10 on Wednesday morning, and 2 to 3, that's another 2 hours, and then 2 to 3 on Thursday afternoon. So those are my advising slots. However, yesterday, Tuesday, I had 0 students sign up. So I was in the office the entire time from actually before 2:15 up until my class started at 5 o'clock. I had no advising I had to do. Today, I don't think I have more. I'm sorry. Today, I had none this morning. Okay. So I was in the office from 8 until 10:15 or what? Yeah, 10:30. No, 10. Wait. No, 10:30. There it is. And actually was here after 10:30. I got back here well before 11:30. Okay. But on Monday and Wednesday, that's it. Okay. On Thursday, it's still just office hours in the morning. And then 15 minutes just to swap books out and stuff like this. And then after lunch, office again for 45 minutes, office and advising for an hour if they sign up, and then office hours until 5 o'clock. So there's my schedule. The college is closed on Fridays. However, I will be checking emails. I will be printing off assignments. I'll do a variety of things on Fridays. However, my wife has a really good long honey-do list that I will be doing also on Fridays. So I won't be in the office most of that time. Any questions on my locator card? That's why I wanted to show you that there may be some times when it says office advising, if you can't get through to me, the odds are I'm advising a student at that 30-minute slot there. Okay. Any questions on this? Okay. So I'm going to get out of... Say again?
I think we got it.
All right. Good deal. Thanks. Okay. Now the screen sharing is stopped. I'll come back to it in just a minute. Let me go back to here and let's talk about the research paper. Okay. Let's go back to the syllabus if I can find it again. I think it's under Google Chrome. Yeah, there we are. Okay. You can see my the blackboard again, right? Everybody? Anybody?
Yes. Blackboard.
Okay.
Yes.
Okay. Why it went back to that, I'm not sure. But let's do research paper. I'll try to make this as quick as possible. Hey, I must have botched something up here. I've got my locator card in twice and don't have the research paper instructions. Hang on a moment. Sorry about that. I'll get this corrected on Blackboard. You probably can't hear me now. Let me go to... yeah. Let's see. Okay, can you hear me again?
Yes, sir.
You can. Okay, I couldn't tell if I was still in Zoom. Okay, my research paper instructions are on a different flash drive, and I'd have to close down the things that I'm using off this flash drive because the two of them, one of them's too fat and the other one won't go in the slot next to it. So I'll talk about research paper next time. Basically, you choose a topic, anything to do with calculus. It can be people, it can be events, it can be applications. I really like application papers. You know, how you use it in your field, how you use it in your something of interest. You might be into astronomy. That's a pet project of yours. How you use calculus in that. You know, just anything will be a good paper topic. I'd like you to write down in the next week and send to me your research paper title, okay? The only reason I do that is to get you thinking about it early in the term so you can get started on it early in the term. And that also provides me, if two people choose Isaac Newton, I'll say, this one's already been chosen. Maybe you want to focus on something about Isaac Newton. Maybe his time at Cambridge, his writing of the Principia or something. So, you know, his rivalry with Leibniz, you know, you could do anything such as that. I just don't want two papers on the same topic. So the sooner you get me your topic, the sooner that is your topic, and you won't have to modify. Okay, so do that as soon as you can. Now, how long's the paper? I want it at least one full page of text. Now, what I mean by a full page of text, if you have a header up at the top, I don't know if you can see my cursor there going around in a circle near the top of the page. If you have a header there and then the title and then you triple space and you finally start typing right over here, one page of text will go to the bottom of that page and on the second piece of paper come down from the top at least that far. That's a page of text. It's guaranteed to be more than one piece of paper. Guaranteed to be at least two pieces of paper, okay, in order for you to come down to the same point. I want it double spaced, not single spaced. Double spaced and standard font. I don't want any tiny font. I don't want any huge font. Standard, something like 12.12 pitch, whatever they call that, okay? And a readable font. Don't get anything fancy on me that I can't read. Keep it something simple, easy to read, okay? Format, I don't care what format you use as long as you're consistent. Most English classes teach, what is the name of that one? Oh, goodness, I'm going blank on it. MLA, Modern Language Association format, right. MLA format, perfectly fine with me. A lot of science classes and courses and fields like to use something like APA, which is American Psychological Association. They came out very early in the game with a very nice, readable, easy to use format, perfectly fine for me. Joy must have had to leave, and she's coming back. Okay. I'm a member of several professional organizations. It seems like every one of them has their own format. Okay. Use any format you're used to, but be consistent. Okay. If you start blocking paragraphs, block all your paragraphs. If you start indenting your paragraphs, indent them all in the same way. If you start in one font, stay in that font unless there's some reason you need to change it for emphasis. Don't use italics to do the whole paper in. If you want to emphasize something, italics are fine. Or color or bold or anything else, be consistent. Okay. Also, be consistent in how you make your references to your citations, okay? I've seen students do this before. They'll get to some place and make a citation and use one thing like open parentheses, author's last name, comma, title, close, or something like that, whatever their thing calls for. But then later in the paper, they'll have a very similar one, not the same, but very similar, and they'll use a different format, like the title of the article, comma, page number. Hey, what's going on here? Well, I know what's going on. The first one, when they were making a reference there, they probably used the format that reference used in their paper, okay? And then when they use a different one, they use the same format there, okay? You choose your format, and then you make your citations according to that format, okay? Don't be switching around for some reason, okay? Keep it consistent. Sources. You need at least one outside source. Guess what? This book is not an outside source, okay? Your regular textbook is not an outside source. The text that you're using in the class is not an outside source. That's one of the purposes of this, get you out of the book, at least acting like you're going into the real world somewhere. So anything you get from the library or any reliable thing you get off the internet. Too many things on the internet are total garbage, so be very careful. If you're in any doubt of the validity of something as a source, run it by me before you start using it. There's so much out there on the internet that's total garbage. Don't get fooled. Okay, so when is it due? Due by the last day of class. That's not the final exam day, the last day that we meet as a class. That will be when it's due. But please do not wait to turn it in until the last day of class. I'm going to have enough things to grade at that point in the term. So now if you turn it in after that last day of class, like during finals week or something like that, you lose points, okay? That's the stick. Here's the carrot. If you turn it in the month of May, and we only have a few days left in May, but if you turn it in the month of May, you get 2 bonus points added to whatever your score is, okay? If you turn it in the month of June, you get 1 bonus point added to whatever your score was. If you turn it in the month of July, you get your score, and that's it, okay? If you turn it in after the last day of class, then it's going to lose points, okay? So please get it started early, get it done early. You'll never have more time to work on the paper than you do right now. So please get started, get it done, get it into me, okay? One more thing that I require is I want you to submit with your paper a single page from one of your sources. Let's say you had 3 sources, pick a source, any source. And then if that was a book or a magazine, a journal or something like that, take it over to a copier, copy me a single page from that, submit that, scan it, do whatever you want to do with it, submit it with your paper. If, however, you got it off the internet, you can just print me a single page. I don't need the whole article, just a single page from that source, okay? And submit it with your paper, okay? Now, spelling, grammar, all that kind of stuff counts, okay? Maybe not as harshly as it would in an English class, but it does count. But also content matters. If I've had some weird things I've been told in papers I knew were not true. let's just take a dumb example, Pythagorean theorem, I've had it stated incorrectly, or I've had a person's birth date or death date way off a century or so, okay? I will catch most of that stuff. So content also matters as well, okay? Any questions on the paper? Like I say, I'll get them out there sometime, hopefully this evening. I'll get this corrected and you can read through the thing under Blackboard. I showed you the right place. I just have the wrong thing loaded there, okay? It says research paper instructions, but I loaded my locator card twice. Sorry about that. Next, any questions so far? Now, Amina's question about WebAssign key, here it is. Here is the class key, the second line here. This just identifies which one it is. That's when I copied it, I made sure I had this class, the right class key. That's what you use for the WebAssign key. If you are using the Cengage Unlimited, if you want to use WebAssign, that's your key for this course. Okay? Any questions on that? Okay. Now, here are the YouTube videos. This is a link, so all you have to do is just click on this and it takes you right there.
Thank you so much.
Okay.
All right.
All right. There I am talking. I'm
think this
going to
is
have a
where
hard
we
time
left
muting
off,
this. Let me
yes.
see.
Last time.
Wow.
So let's pick up.
This is the first time ever that I've had voice when I've shown this.
All right.
Okay, I muted it. Hopefully you can unmute it. Okay, let me explain some things here. These are sections that I did. Remember I said I used to have a writable screen? There's one. You can see my writing on the screen. Okay? Well, that's a 238. I don't know why that's showing up here. But anyway, that's how my writing looks on the screen. It's pretty pathetic. But I teach from Blackboard. I write on Blackboard, just like right here. Okay, you can see that one. These are the older ones at the top. Always the most recent are going to be at the bottom. So the things at the top are the oldest. I put the section numbers and all like that. A few of these may be from an older book because we did change editions, so don't let that fool you. But the last time I taught this course, in fact, the last time I taught it was in an older book. So not everything here will match up, but it's the same author, okay? The chapter numbers may be wrong, off. The page numbers I refer to, they'll be off, but the material is basically the same. And what you get out of this is, and the last time we got through, that looks like the sequences and series. That's as far as we got. This was sometime several terms ago, okay? But anyway, most of the stuff you'll find here. There is one thing in Chapter 5. I don't think in this book, Chapter 5 was the same as the Chapter 5 in this book. That may be what the Chapter 4s are here. But you'll just have to look around and see. Like I said, the books did change. Here's Chapter 5s and Chapter 4s. I can't tell looking at this. This looks like integration to me. So this is probably the integration chapter here. But anyway, if you need it, I'm going to leave them up here because they have worked out problems on them. I'll be adding the new ones at the bottom, okay? And when you get to the bottom, you'll see, after this class, it'll be sometime this evening, I will get it loaded, and it'll say Math 126 Syllabus, even though we're covering more than the syllabus, okay? But that will replace, and I'll probably take off, somewhere in here, you'll see one that says Math 126 Syllabus right there. I'll take off this one and put on the new one, but it'll be at the bottom. It won't be here. After this, I won't be removing the older sections. I'll leave them out there, okay, because they have worked out problems on them. Okay, any questions on that? That's the YouTube video. That's how you get to them. It's there. I forgot. You can see this, can't you? It says I'm screen sharing. Can you see the YouTube videos?
Yes.
Okay, good deal. All right. All right, the PowerPoints. And hopefully I've gotten these done too. Now, just a few things. These are documents. That's what this symbol stands for. This is a web link. So that's what that symbol stands for. This is a folder. The folders, you can go over here to the arrow and open the folder. Okay, and there are way more than all the sections we'll be doing, the YouTube video, the PowerPoints. There's section 5.1, 5.2, 5.3, all the way down until 11.6. We don't do chapter 6 because that's differential equations. You have to let it catch up a little bit. Way more sections than we'll ever cover in the class. But it's everything we could potentially cover. And it goes through, like I said, 11.5. That's where the class ends. Okay? So if you want to get them ahead of time, you can. If you want to write on them, print them off and write on them, take notes on them, whatever you want to do with the PowerPoints, they're there. Now, these next several links here, Visual Calculus, Education Portal, Prof. Rob Bob, Slater, those are all sources that either I found or a student has found and said, hey, we found this helpful in the class, so I'll put it on here. Some of these are tied to the text, and if they are, they may not be the current version of the text, okay? But they'll be the same author or a similar text. They don't update these all that regularly. Prof. Rob Bob is sort of like Khan Academy, I think, okay? It's just him talking. I didn't mean to do that because he's sort of obnoxious, but anyway. Oh, I've still got it muted so you can't hear him. Okay, so anyway, those are those links. You may or may not find them useful. I put them there in case you need somewhere else to go to look. Here's our library link. This is Lawson State Community College library link. You may find this helpful when you're doing your research papers. So I put it out there. I've not navigated it, so I can't give you any help on that, but I think they do a pretty good job of making it pretty simple. That's it for the Blackboard. Any questions on Oh, no, that's not it for Blackboard. Remember I said you can send me, okay, back off just a minute. I make the announcements here under announcement. That's the announcement for the Zoom link, okay? That's where that is. Everything else pretty much I'll do, like test or other things like this, I do under messages, okay? These are for people who aren't used to this new Blackboard. This is the grade book. I don't know how it looks on the student side. I'm not going to open it on this side because you don't need to see everybody else's. Nobody has any grades in there anyway, okay? This is the messages. So I'm going to click on this, and you'll see there's no messages here now. If there was a message from me, it would say from Charles Fowler to all or something like that, or to you individually, it could be. Now, when you're submitting a test, you can either, you got several options. If you have a scanner at home or at work or somewhere that you want to scan that, get it in a PDF file, and send it back to me either attached to an email, that's fine, or attached to a message, because a message you can do an attachment on that. Okay, if you don't have a scanner, okay, then what you can do is take a picture with your cell phone, smartphone, and attach that to an email or to a message, either one. Okay. If neither of those works or you have good enough technology to do, you can actually mail me your message. Your test or whatever. That's going to be a bit slower and maybe not to be as reliable, and you certainly won't get immediate feedback on it. Okay. But when I receive an email from you, I try to answer it. Okay. Like I received the research paper, I've printed it, I'll grade it when I can. Okay. I'll place the grade on Blackboard. Or if you send me something like this through a message, I will also do it there. Now, the dean likes us to use the messages here on Blackboard. Frankly, I don't like messages as well as I like emails. And here's why. When I get your message, get your paper, get your test, get whatever it is that you sent me, or just the message, and then I respond to it, then I delete it from the messages, because otherwise my message box would be so full I might miss something. Okay? Well, when I delete those, they disappear. The old Blackboard, they would still be in my Outlook, okay, our email account. In this new one, they don't show up anymore. So if you say, but I sent you the second page, but it didn't print when I printed the second page, I can't go back and see if somehow something screwed up there. Once I deleted it, it's gone. If you send it to me by email, I'll delete it, but it'll be in my delete folder and I can't access that. So please do whichever is most convenient for you, but if they're equally convenient, then go with email. But if you find this more convenient to use, perfectly fine to use it. I will be checking these and I'll respond to these just as well. Okay? Now, any questions then on Blackboard? Just what the icons are. This goes back to the content, which we were looking at before. This is the calendar, which I don't really use. This is discussion board. I don't really use that. Here's a grade book. I will be putting your grades in there. Here's the messages. We'll communicate through that. I don't remember what's the one behind Jalen here, but whatever it is, I don't think I use. Okay. Any questions on Blackboard? All right. Then let me get out of Blackboard. I'm sick and tired of it. Okay. And this will probably lose me the screen sharing. Okay. And let me go and see if I can pull up Blackboard now. PowerPoint. There it is. So we actually get started in class. Any questions on anything before we begin? Okay. Go from current slide. Now I have, okay, first, can you see the PowerPoint slide?
Yes, sir.
Okay, good. All right. Let's see. I've lost my clock here. 1:17, we go until 2:25, right? So we have a little over an hour left. Y'all can get up and go to the restroom anytime you want to. I can't. So I'd like to take a bladder break here if we could. I'm going to pause the screenshot here, but I'll leave Zoom open. But it's going to be some dead time. All right, I'm back and the recorder started again. And just, are y'all still there on Zoom, right? Somebody say something.
Yes.
Yeah,
Yes,
okay.
sir.
Now, I have another question for you here. Okay, first, can you see the Chapter 5 integration sign, PowerPoint?
Yes.
Yeah, okay.
Yes.
Can you also see this corner thing over here, which has the a red circle with two vertical black lines and a time going next to it? Can you see
No.
that?
No, sir.
You cannot see that. Okay, I was just going to say, if you can see that and you ever see that I did not click on it to start it recording again, please let me know. But if you can't see it, you can't let me know. So anyway, let me move the screen sharing line out of the way here. You probably isn't bothering you any, but it does bother me. Okay, Chapter 5. Sorry about this for you folks that were... Whoa, here's somebody just came in. I didn't recognize the name. It looked like Ron's. Who just came into the class? Let me see if I can find you here. Maybe it's someone that was already here.
It's
Who?
somebody that was already here.
It was. Okay, good. Okay. Oh, it was probably Lauren, wasn't it? Yeah, that may be who it was. Okay. So, all right. Now, Amina, it is Amina Kelly, right? Yeah. You were in Miss Martin's class, Cal 1?
Yes, sir.
You were? Okay. Did y'all get through chapter 5, integration?
We did.
You did. Huh?
Yes, we did.
Was it last spring or was it earlier?
It was last spring.
Oh, okay.
But
Well,
we were kind of faced with the same situation y'all were, so we kind of had to rush through it. So I know how to do it, but it would help me, for
okay.
the review.
Well, we're going to do it, but we'll try to do it rather quickly, okay? And I'm sorry. I apologize to the rest of you. You've already had it. Hopefully, you'll find maybe the review is useful. Okay, chapter 5 is integration. And the page down doesn't seem to be working. Goodness gracious. Let's see if this will work. This is the first time I've used Blackboard on this new computer, and it advanced for me before. There we go. The arrow key works. 5.1 is antiderivatives and indefinite integrals. Okay? The objectives here will write the general solution for a differential equation. Now that's rather bizarre. They're talking about that now, but that's what we're doing. And we'll use indefinite integral notation for antiderivatives. Use basic integration rules to find antiderivatives and find a particular solution of a differential equation, which again is a little bizarre because differential equations is a course several terms away, okay? So let's start with antiderivatives. Exactly what it sounds like. If you think about mathematics in general, one of the first things you did after you learned to count, when way back in schooling, kindergarten, first grade, whenever it was, the first operation you learned was addition. And boy, they drilled you on addition, and you learned addition, you memorized addition, you did flashcards, whatever you did for addition. And then what you thought, hey, I've just about got this done. What did they do? They turned around and made you learn subtraction, which basically undid addition. Well, you went through all that, and then guess what? Here came multiplication. Once you finally got all that down, what did they do? They had you undo multiplication with division, okay? And then at some point later off in your career, you ran into powers, okay? Raising a number to a power. Well, sometime after that, you started taking roots, which undid powers, radicals, okay? And then over the time when you got to algebra, pre-calculus algebra especially, you got to functions. And somewhere along in functions, you ran into inverse functions, which basically undid what the previous function did, okay? Well, in calculus, what you spent most of last term doing was learning differentiation, okay? Now we're going to undo differentiation by taking antiderivatives, okay? So here's what we mean by antiderivative. To find a function, capital F, whose derivative is this little f. Now this is just the convention they use. There's nothing magical about capitalization and lowercase. You could reverse them, you could do whatever, you could call them different names. It doesn't matter. This book just calls them, and it's pretty standard. So let's say you know the derivative is 3x squared. Well, most of you could probably think about the power rule and say, yeah, I think I know where that came from. You might use your knowledge of derivatives to conclude that the f of x, whose derivative is 3x squared, must be x cubed. Why? Because when you take the derivative of this, you take the coefficient times the exponent. 3 times 1 is 3. Keep the base the same, x, and lower the degree by 1. That's the power rule, okay? Because the derivative of x cubed is 3x squared. So we say that capital F is the antiderivative of little f. If you started with little f, you're going backwards, you might think, in taking derivatives, taking an antiderivative to come up with the original function. So there is the definition of an antiderivative. A function f is an antiderivative of little f on some interval I. Now, we haven't said anything about the interval yet. When f prime, the derivative of this capital F, is equal to the little f. That's what it means. The derivative of capital F is little f, therefore little f is the antiderivative of capital F for all the x's in the interval. Okay, now this function up here, polynomial function, they're defined everywhere. So the interval of that would be all real numbers. Okay, so we didn't even mention it because it would be good anywhere. Other functions, however, may have more limited domains. So then that would be help determine what interval you're talking about. Okay? Now, one other issue here. This little article here, and they didn't say a function f is the antiderivative of little f on an interval. They said an antiderivative, which leads you to think, and you would be right, there's more than one of them. Okay? And we'll get to that in just a little bit later. Okay? Now, f is called an antiderivative here. They keep talking about it. I didn't know they'd come this soon. An antiderivative of f rather than the antiderivative, and here's why. If capital F was x cubed, its derivative is 3x squared. But what if capital F was x cubed minus 5? Its derivative would be 3x squared minus 0, which is 3x squared. Or capital F could have been x cubed plus 97. Its derivative would be 3x squared. Because 97, the derivative is 0. It doesn't matter. These are all antiderivatives of 3x squared. So to keep from listing them all, because you can't, there's an infinite number of them. We just hit a couple of integers there. You could put irrational numbers, you could put fractional numbers, you could put decimal numbers. There's an infinite number of constants you could put after that. So in fact, for any constant capital C, now most of the time I put little c, but this book likes capital C, the function f of x is equal to x cubed plus c is an antiderivative of f. I would say the antiderivative, because you can plug in any value c that you want to put. So maybe they still need to put an, but that. So here's theorem 5.1, representation of antiderivatives. If capital F is an antiderivative of little f on some interval I, then capital G is an antiderivative of f on the interval I, same interval, if and only if G is of the form capital F plus C. So in other words, G and capital F differ only by a constant. For all x's on that interval I, and G is any constant on that interval I. That could be positive numbers, negative numbers, fractions, decimals, rational, irrational, any number. Now we're going to stay pretty much in the real number system. We're not going to be going out to complex numbers with imaginary components. So don't worry about complex numbers there. Still probably going to be true, but we're not going to worry with those. Okay? All right. Now, using that theorem, you can represent the entire family of antiderivatives of a function. And let's see, somebody else is trying to get in. I didn't see the name there because my thing was blacked out. Did y'all see who that was? Still 16, so I'm guessing it's someone who was here who just came back. Can y'all tell? Okay.
It was me.
Okay, good. Welcome back. Okay. I just want to make sure I don't miss somebody coming in new because I want to count you present if you're here. Okay? So using that theorem, you can represent, we're, by the way, on, if you got this or some other text, we're in the first section of the chapter on integration, which is covering antiderivatives and indefinite integrals. If you're in our text, that's page 284, but some other text, it's probably a different page number. Okay. So using theorem 5.1, which we just had up there, you can represent the entire family of antiderivatives of a function by adding a constant to a known antiderivative. So example, you know that the derivative with respect to x, that's what this notation stands for, derivative with respect to x of x squared is 2x. So you can represent the entire family of all derivatives of f of x equal 2x as being x squared plus c. Now, for some reason here, they jump from capital F to little f to capital G. I don't know why they do that stuff like that. It doesn't matter. You can call it anything you want to. So this represents the family of all the antiderivatives of 2x, x squared plus c, where c is any constant, and that's called the constant of integration. Okay? That's going to be a pretty important thing when you get to physics and other fields such as that constant of integration. Okay, I can't get it to advance. Okay. Things do some strange things here. Like I believe every time I check something on Zoom, then my cursor doesn't work and I have to do something else. Okay. So, continuing antiderivatives. The family of functions represented by g is the general antiderivative of f. So, g of x equal x squared plus c, general solution of this differential equation, g prime, that means the first derivative of g with respect to x, that's what g prime means, equal 2x, then that means g must be x squared plus c. Take the antiderivative of this and add an arbitrary constant to it. And frankly, it doesn't matter if you put capital C or little c. I don't care. It's just as represents a constant. So this is called a differential equation. To be a differential equation, you have to have a derivative somewhere in that equation, and you have to have an equal sign. Derivative, differential, that's where that comes from. Equations mean there's an equal sign. So some derivative is equal to something else. Okay? And that differential equation in x and y is an equation that involves x, y, and the derivatives of y. Notice you could have more than one derivative. First, second, third, fourth derivative of y. Okay? So here's another differential equation. Y prime, which is dy dx, okay, however you want to say it, equal to 3x. What would be the solution to that? Y equal, well, jumping a little bit ahead here. If y prime is 3x, then the y must have been an x squared here. But when you took the derivative, you'd have something over with a 2 in it. So this would have been, let's hold off. I'm jumping ahead. Okay. Here's another differential equation. Y prime is equal to x squared plus 1. Those are examples of differential equations. You have a derivative and you have an equal sign. Okay? We'll get to the other part later. Okay. So, let's solve a differential equation. Now, this is where pull out your pencil and paper and be ready to write. I'm going to use a pen just because it shows up better. Okay? So here's your differential equation. dy dx is equal to 2. Okay? Now, there's lots of ways to approach this. Here's how I remember approaching it back when it was new to me. What function, when you take its derivative, is going to give you just the letter 2, the number 2? Okay? Now, remember here, pointing something out, dy dx, that indicates y is the dependent variable, x is the independent variable. Okay? So therefore, your answer is probably going to have an x in it. It's not going to have a y in it. That's what's going to, when you undo the derivative, you're left with y. But now you may have introduced an x. So that sort of gave it away, I hope, that y is equal to 2x plus c. Okay? Does that make sense to you? If dy dx is equal to 2, then y would have to be 2x plus c.
I have a question.
Yes.
Are you writing that down or on the
I'm writing it and holding it up in front of the camera. I'm writing it on a piece of paper. Can you see it
We
in?
can't see because it's still on screen share.
Okay, well, it's you. Okay, you don't see me at all anymore. Is that right?
I see you. I see what you're telling us to do.
Okay.
You're across the bottom, so we just have to switch back and forth between the two.
Okay.
I can see.
Okay. If you can see me, you should be able to see that. Can you? You said yes.
Yes, sir.
Okay.
Yes.
Now, can some of you not see me? It sounded like you can't, right? Jesus, you cannot see me?
That's just, I thought you were sharing like that screen, but never mind. I get it.
You do. Okay. So you can see that?
Yes.
Okay. Got it. All right. You just have to open it up so you can see my camera. Now, if you're working on a cell phone, that's going to be difficult, I guess. But get used to going back and forth. That's all I can do. My old computer used to have a stylus, an ionizing pen. I could have written right here on the screen and worked out the problem for you. I can't do it anymore. This does not have that capability. Okay? I miss my old computer like crazy. Okay? Now, and by the way, if you're in the book, this is on page 285. Okay? So.
We ain't hear none of that.
What's that?
I didn't hear anything you just said right there.
Okay, going from how far back? What's the last thing you did here?
It was like the last 10 seconds when you moved away from the mic.
Okay, when I said we're on page 285, is that all, or did you?
Probably.
Okay, yeah, that's all I was saying. That for example 1 is on page 285. Okay, now, I don't know if you'll find this helpful or not, but I'll try to do it. Now again, get it so you can see my camera. This is a heavy book, so I'm not going to hold it too long. Can you see that graphic there? 3 parallel lines?
Mm-hmm.
You can see it. Okay. That represents 3 of the infinite number of solutions for different values of C. Okay? Because when you say that the derivative of a function, dy dx is equal to 2, basically that means you got a straight line whose slope is 2. Well, all 3 of those straight lines have a slope of 2, don't they? And you could draw an infinite number of those straight lines that have a slope of 2, and that would be the difference. They'd all be parallel to each other, every one with a slope of 2. If you remember back for derivatives, that's what a derivative told you. The slope of a tangent line. Well, if it's a straight line, the slope is its tangent line. Okay? And they showed you 3 values, c equals 0, -1, and 2. And you'll notice in that form that we have y is equal to 2x plus c. When c is -1, your y-intercept is -1. When it's 2x, the y-intercept is 0. When it's 2x plus 1, the y-intercept is, or 2x plus 2, whatever it is, those are the y-intercepts, and you see on the graph, they do intersect the y-axis at those points. Okay. Now, that is one way to talk about I've lost my pen now. I do this all the time when I'm picking up books and doing around. My pen chooses to disappear. And where it goes, I've never figured that out. I don't see how it could. I haven't moved here. And yet the pen is nowhere to be found. I don't remember hearing it hit the floor. Yuck. Oh, there it is. Too many moving parts. Okay. Now, this is jumping way ahead, and I found it interesting the book did it this way. Well, let's see. Maybe I can pick this up on the slideshow. Let's see if it will. Here's how they do it. To begin, you need to find a function whose derivative is 2. Well, basically, you undo a power rule, okay? You would need to have a function of x, because that's the independent variable here, is x, that when you take its derivative, it's going to give you 2, okay? Well, if it's a power, that must be x to the first power, because when you reduce a 1, you got x to the 0th power, which is 1. So it would have to be an x, and sure enough, y is equal to 2x is that function. That's just one of the functions. To get the general form, you say y is equal to 2x plus c. So now you use the theorem to conclude that the general solution of that differential equation is 2x plus c. 2x is that first term of it, and then put the plus c to cover any others. Okay. Now, and there's the graphs. I need to hold the book up, did I? The graphs of several of those functions, 2x plus c for several values of c. When c is equal to 2, y is equal to 2x plus 2, that means the y-intercept is 2. There it is. There's that line, slope of 2. When it had just y is equal to 2x, where c was 0, the y-intercept is 0. It goes to the origin. When c is equal to minus 1, y is equal to 2x minus 1, y-intercept is minus 1, same slope of 2. Okay? So those are your functions of the form y is equal to 2x plus c. What we sometimes call that is a family of functions for various quantities c, for the various constants. Okay, now here's what I thought I was going to have to write, and then I realized, hey, maybe this is on the slideshow. It is. When solving a differential equation that's in what I call derivative form, a derivative is equal to some function of x, even though there was no x in it, but you know it's a function of x because the independent variable is x. It is convenient to write it in the equivalent differential form. Now, this is what we were covering right at the end of the term for those people who were in my class. Differentials, you basically, it looks like you're multiplying both sides of the equation by dx. Don't say that in front of a pure mathematician. It'll make their hair curl, okay? They don't, because this is an operator. It's not a division sign. But that's exactly what it looks like you're doing. dy is equal to f of x dx. This is a differential form of that derivative equation. This is a true differential equation, but we call both of those differential equations, okay? And that operation of finding all the solutions of that is called anti-differentiation or indefinite integration. And that's where the integral symbol comes from. If you integrate both sides of that equation, then you have the integral of dy. Well, an integral undoes a derivative, just like subtraction undoes addition, like division undoes multiplication, like a root undoes a power. Inverse function undoes the function. A integral undoes a derivative. That leaves you just with a y here. An integral here then undoes this function, takes its antiderivative of this function in terms of the variable x. So that's where the integral sign comes from. Now we'll see another way we get the integral sign, which to me makes a lot more sense. They just introduce it here as if that's what the integral sign means. And it is what it means, but it really has more meaning than that. We'll get to that a little bit later. So the general solution is denoted by y is equal to the integral of f of x dx. That would be capital F, which is the antiderivative of little f, plus your constant of integration. Don't forget your constants of integration when you're doing indefinite integrals. When there's no numbers associated with that integral sign, that's called an indefinite integral. So that expression, integral of f of x dx, is read as the antiderivative of f with respect to the independent variable x. So the differential dx serves to identify x as the variable of integration of your indefinite integral. Okay? I've got something in the way here that I can't see. For some reason, Zoom thinks I've got something here and it's trying to mask it out. So the term indefinite integral is synonymous with the term antiderivative. So if you integrate something, you're taking the antiderivative. So let's make sure I'm not skipping anything here. Yeah, let's go to our basic integration rules. The inverse nature of integration and differentiation, like I've already said, can be verified by substituting f prime for capital F prime instead of little f in the indefinite integration to obtain the following. And this, they're really going for it here. The antiderivative of the derivative of capital F of x, well, that almost gives it away. The antiderivative of the derivative, this undoes the derivative. So therefore, you just lose the derivative, lose the antiderivative, you just get f of x plus c. You have to remember the plus c anytime you have an indefinite integration. Moreover, if the integral of f of x dx is f of x, capital F of x plus c, then you know that the derivative of your antiderivative of f of x, here the derivative undoes the antiderivative, think of that as the integral sign, and that leaves you f of x. Now notice on this one you don't need a plus c, because when you take a derivative, if you had a constant out there, derivative of a constant is 0. So you don't put a plus c when you do the derivative, you take the derivative of an integral. If you take the integral of a derivative, you do put a plus c at the end. Okay? Just keep that in mind. It's basically the inverse operation of integration differentiation is. Integration is the inverse operation of differentiation. The only big difference is when you integrate last, you differentiate first, then integrate, you have to put a plus c. When you integrate first and then differentiate, you don't need a constant at the end. Okay? Not necessary. Okay. Can I move on? Are there any questions? Okay. Now, those two equations allow you to obtain integration formulas directly from your differentiation formulas as shown in this summary. Because we know that the derivative of a constant is 0, therefore if you integrate nothing, you get a constant. In other words, you're integrating a term with nothing in it, 0, you're going to get a constant. Why? Because the derivative of that constant is 0. Okay? Always you can go back and take the derivative of this and make sure you get that. All right, now just like we did before, the derivative of a linear function, kx is equal to k, the slope of that linear function, exponent times coefficient, 1 times k is k, reduce the exponent by 1, 1 to 0, x to the 0th power is 1. For some reason my cursor disappears. So that's k. So if you integrate k, you're going to get kx plus c. Always remember you have a c at the end, okay? Kx plus c. Okay, so in other words, you're adding the variable back again, increasing its power. We'll talk about what goes into the coefficient later. Now, here we have the derivative of k times the function f. We don't know what the function is, but we know from our integration rule, differentiation rules, that you can pull the constant on the outside, and that would be k times derivative of f of x. Well, derivative of f of x you could write as dy or df dx, or you could write it as f prime. Remember, just two different ways of writing a derivative. Well, if you were integrating that f of x dx, then what you would do, pull out the k can go outside the integral, and that would give you the integral of f of x dx. Now we don't know what that is. We've been calling it capital F of x plus c, but you can leave it just like that. That's just saying if you're integrating a constant times a function, pull the constant on the outside and just integrate the function. Okay, that leads to yet another. If you differentiate the sum or a difference of two functions, okay, now this is, of course, assuming these two functions have the same domain. Okay? Certainly if they don't have the same domain, you can't do it. You have to just take what part of the domain are in common. But we're just assuming they're going to be the same. If you're taking the derivative of a sum or a difference, that's just the sum or the difference of their derivatives. Okay? Just like we did in differentiation. That is what we did in differentiation. So in integration, if you're taking the integral of f of x plus or minus g of x, split that into the integral of f of x dx plus or minus the integral of g of x dx. Okay? Just like the derivative of a sum or a difference of two functions is the sum or difference of their derivatives. The integral of a sum or a difference of two functions is a sum or the difference of their antiderivatives or integrals. Okay? Now, to the power function. We know that the derivative of a power function, x to the n, you take the exponent n, multiply it by the coefficient of x, and reduce the power by 1. Okay. Now, we're going to be doing this in reverse. And unfortunately, I have this sorry box here right in the way. Okay. Now we're doing the integral or antiderivative of x to the n. Well, what you do, remember here, you multiplied the n by the coefficient. Here, you divide the coefficient by n. You can't see it here. I'm sorry, not by n minus 1. I wish this thing would go away. Let me go back. I got my wish, didn't I? Okay. Here, let's go back to the differentiation. Goodness. My cursor, there it is. Okay. You multiply the coefficient by n and reduce by 1. Well, to do an integration, we're going to increase the power by 1, going in the opposite direction. So that's going to give you x to the n plus 1. But then you divide. Here we multiplied. Here we'll divide by the n plus 1. Okay? Now, of course, this will not work if n is equal to negative 1. Because if n is equal to negative 1, you can't divide by 0. Ever. Not even in antiderivative. Not even in calculus, you can't divide by 0. So this is the power rule as long as your n is not negative 1. A little bit later, we're going to hit what function you get when n is negative 1. You can integrate it, but it's a whole new function. Okay. So let's move on. Okay. Now, here's your integration rules. Here's your, differentiation formulas. Here's the integration formula. Because we know that the derivative of sine is cosine, positive cosine, y'all remember that, right? So the integral of cosine, or the antiderivative of cosine, is positive sine. Plus c, always remember your plus c, even with trig functions, or any kind of function, you have to have the plus c if that's an indefinite integral. And because the derivative of cosine is negative sine, then the antiderivative of sine must be negative cosine, the reverse. And this will trip people up, I guarantee. You're used to taking derivative of sine to be positive cosine, derivative of cosine is negative sine. When you go the other way, take the integral of cosine, it's positive sine. The antiderivative of sine has to be negative cosine. Why? Because the derivative of a negative cosine would be a minus of a minus sine, which is a plus sign. But you have your plus c. Because the derivative with respect to x of tangent is secant squared, you all remember that, I know, then the antiderivative, or the integral of secant squared, has to be tangent x plus c. Now, derivative of secant x was secant x tangent x, so the antiderivative of secant x tangent x must be secant x plus c. Derivative of cosine x, you may not have remembered this one, but it's true. Derivative of cosine tangent x is minus cosecant x, cosecant squared x. So the integral of cosecant squared x would be minus cotangent x plus c. And the derivative of cosecant x is minus cosecant x cotangent x. So the integral or antiderivative of cosecant x cotangent x has to be minus cosecant x plus c. Okay. Now, I don't know if this was emphasized before. I tried to emphasize it to my class. Notice when you're taking the derivative of the core function, sine, tangent, where my cursor goes, I don't know, tangent, or secant, those are always positive. Okay? When you're taking the derivative of a cofunction, cosine, cotangent, and cosecant, those answers are always negative. There's nothing magical about that. That's just how I remember them. But then when you're doing the antiderivative of the cofunctions, cosine, cosecant squared, and cosecant cotangent, those are going to be negatives. I'm sorry, I said that wrong. Forget that. Remember it for differentiation. Don't worry about it here. For sine and cosine, it works. The antiderivative of cosine is positive. The antiderivative of sine is negative. Forget about what I was going to say otherwise. Okay, let's move on. A few more. Now, here is where we run into, I forgot that this book, unlike the previous book I taught from, separated these. These bring in your transcendental functions. Because the derivative of e to the x is e to the x. My favorite function of all time to take a derivative is my favorite function to take an antiderivative. Because the antiderivative of e to the x is also e to the x. Plus c, of course. Okay? Now, for any other exponential function with a base other than e, derivative of a to the x with respect to x would be the log of a times a to the x. The only difference here is a to the x, but then its preceded, its coefficient is log of a. So when you're doing the antiderivative of a power function, an exponential function, that's going to be a to the x, just like it was e to the x here, but now it's 1 over. Here you multiply by the log a, here you divide. You're doing the anti, so you're doing that. And of course, you still got a plus c. And the derivative of log x, if you remember this, is 1 over x. Or another way to express that is x to the minus 1. So here's that integral we said wouldn't work in the power formula when x was equal to minus 1. Integral of x to the minus 1 would be log absolute value of x plus c. Now, why did we put absolute values there? We didn't anywhere else. Anyone have a clue? You cannot take the log of a negative number. Not defined. So when you're doing an integration, derivative of the antiderivative of 1 over x dx, that's always log absolute value of x, because you cannot take the derivative of a negative number. So it has to be an absolute value. You still have to put the plus c in it. Now, much later, we'll see that sometimes we'll rewrite that constant to be something like log c. Still a constant, but now write it in terms of logs, so then you can use the formulas and properties of logarithms to help simplify your answer. Don't sweat that now. We'll get to that later. Okay? Any questions so far? All right. So here's example 2. This will be top of page 287 in your text. Okay? Now, why they work it out for you, I don't know, but they do. So you're taking the antiderivative of a constant times a function dx, x dx. Pull that 3 on the outside and make it 3 times the integral of x dx. Well, now this is a power rule. Your power here is 1, and since you're doing an antiderivative, rather than reducing the power, you increase the power, okay? I didn't mean for that to happen, okay? So this will be going up to x squared, but then you do divide it by that new power, which is 2, so that would be 3 times x squared over 2. And that's what they're going to show next. Now they put the exponent in there. You don't have to, but if it helps you, do it, okay? And then what do you do to integrate this? The anti of your power rule. Increase the exponent by 1 and then divide by that exponent. So that would be 3 times x squared over 2, and that would be the same as 3 halves x squared. 3 times x squared over 2 plus c. Don't forget your plus c, okay? And then I would rewrite this as 3 halves x squared plus c, and that's what they do. 3 over 2 x squared plus c. Now, because this is probably fairly new to you, here's a simple thing. If you want to check your answer, take a derivative. Derivative of this is 3 halves times 2. Well, the 2's cancel out. That gives you 3x. Reduce it by 1, you get 3x. That's exactly what you want. You started out with here, 3x. You can always take the derivative of this, see if you get the argument here. You did, you got it right. I always like to check my answers. I don't like making mistakes. I make plenty of them, but I still don't like it, okay? Now, the antiderivatives of 3x are always of the form 3 halves x squared plus c, where c is any constant in the world, okay? Now, in example 2, note that the general pattern of integration is similar to that of differentiation. You start with the original integral. You rewrite it if necessary. We used to do that in differentiation too. Then you integrate and then simplify. That's what we just did, whether you realize it or not, we did those. Sometimes you'll skip one of those steps if it's obvious to you. After a while, you'll go straight from the original to the simplified form. That's generally what we do. Okay, now the slide set is skipping examples 3, 4, 5, 6, and 7. Now, I doubt if we're going to have time for all those, but let's get as many of those done as we can. Okay, so let's start with example 3. Now, for you folks who are going to be using a different book, your home book or whatever, if you want to kind of follow what we're doing here and seeing the thinking of this author, certain of these examples, this author has several things that I've not run into an author that does this on other things. I'm going to hold up the book for you in a minute, since most of you are transient students. 100% free, okay? An internet resource at larsoncalculus.com, okay? Any of you can go to that. You don't need a code. You don't need a key. You don't need anything else. Your grandmother could go to larsoncalculus.com and see anything she wanted to read there, okay? It's a free website. It doesn't have to go with this book, but it certainly does go well with this book. But anyone can read it in any book you got, okay? That's one. There's another called calcchat.com. When we get to the exercises, which hopefully we'll get to some today, those or all the odd exercises are worked out at calcchat.com. And certain ones of those exercises are worked out at calcview.com. Another, absolutely, both of those, all three of those, absolutely free, accessible websites. Okay? So if you want those again, it's larsoncalculus.com. Larson Calculus written as one word, no space, no things. They capitalize the Larson in calculus. It doesn't really matter. The other is calc, calcchat.com. Now, they capitalize the first C and the last C, but calcchat.com. And then calcview.com. They capitalize the calc and the view, but calcview.com. Okay. So this example 3, you can go, if you don't have a book, you can go to larsoncalculus.com and find this example. Okay? So I'll work it out for you here. You be working out on your paper. Here is the original equation. The integral or antiderivative of 1 over x cubed dx. Okay? There's your original problem. Can y'all see this? I'm just guessing where it is on the paper. Integral of 1 over x cubed dx. Can you see that in the slide?
Yes.
Okay. Now, first thing I would do, I would rewrite this. Because frankly, I don't like having variables in a denominator. Sometimes you can't help it, but I don't like it. I also don't like radicals. So if you have a radical, I'm going to rewrite it. How would you rewrite that one? Hint, use exponents rather than denominators. The integral of x to the minus 3 dx. Am I holding it where you can see it? Isn't that the same as this? 1 over x cubed is the same as x to the minus third power, right?
Yes.
All right. So now we can use our power rule, okay? The power rule says that you keep your base, x, increase your exponent by 1. Well, your exponent was a minus 3, increase by 1, and you get a minus 2, right? Negative number, increase by 1. Now you divide by that new exponent. So that's divided by negative 2. And then, of course, you have to put plus c. Now, I always don't capitalize my c, but you see what I did there. You went from integral of x to the minus 3, increase the minus 3 by 1, making it a minus 2, divide by that new exponent, minus 2, and then keep the x the same, and add c. Now, I'm going to rewrite that a little bit, okay? Since they gave us the original problem as 1 over x cubed, I'm going to write the answer sort of like the original problem, okay? So I'm going to rewrite that as, I'm going to pull out the negative 1/2 out in front and do, in fact, I'll just put the x in the denominator too, negative 1 over x squared plus c. Now, okay. I don't know if this is how they write their answers, but that's, to me, a very concise, acceptable way to do it. 1 over 2x squared plus c. Now, this plus c should be on the same plane with the line there. I didn't quite write it well. Okay? I don't know if that's how they leave their... that is how they put their answer. Negative 1 over 2x squared plus c. Okay. Now, was there anything wrong with this answer? Absolutely nothing. That's a perfectly legitimate and good answer. Okay? If you had written this as minus 1/2 x to the minus 2 plus c, perfectly good answer. Or 1 over 2x squared plus c, another perfectly good answer. You could probably think of some other ways to write that. My point being, things like WebAssign, looking for one and only one answer, and they'll tell you the others are wrong when they're not wrong. They're absolutely correct. Okay? Now, if y'all have run into the fact that WebAssign is doing better at that and letting you put more than one correct answer and say count it right, let me know and I'll go back and use WebAssign again, maybe. Okay? But anyway, that's what I would suggest. Let's do the B part. The B part says the integral of the square root of x dx. Okay? Now, any of you know the rules for taking integrals of radicals? Is that, yeah, there it is right there. Can you see it? There aren't any rules for taking integrals of radicals. I don't like to even mess with radicals. So guess what my first step is going to be? Rewrite that in terms of exponents, not radicals. So what would that be? You tell me.
It's gonna be 1/2.
X to the 1/2 dx. Okay? Now we've got a power rule. I'll take a power rule any day over a radical. Okay? Now, what's the rule? Increase the exponent by 1, divide by the new exponent. Okay? So that would be, I'll write it out in gory detail here, x to the 3/2 divided by 3/2. And then you put your plus c out there. So this would be, by the power rule, you increase the exponent by 1. 1/2 goes to 3/2.
Can you move it up some?
Up some. Is that better?
Yeah, that's good.
Okay. Yeah, correct me anytime because I can't see. It used to be I could see my picture over here and I could see if I had it centered, but Jalen's in my place now and I can't see. So sorry about that. No, I'm just kidding. Okay. So now that's an awkward way to write this. Let me tell you what I usually do with those. Rather than dividing by 3/2, whoa, goodness gracious. Okay. Dividing by a fraction is the same as multiplying by the reciprocal of the fraction. So usually I don't ever write it the way I just did. I would say that's 2/3 times x to the 3/2 power plus c. Now to me, that's a very decent way to leave that answer. But they may not. Okay? I'll show you another way. Since the original problem had a radical in it, if you wanted to, for some reason, put a radical back there, here's 2 more ways you could write that answer. That could be 2/3 times the square root of x cubed plus c, or 2/3 times the square root of x cubed plus c. Now that sounded like I was saying the same thing, but here's what I was saying. If you wanted to write that back in a radical form, since the original problem was in radical form, that could be 2/3 times the square root of x cubed. There's the 2 in the denominator. Say again?
It's to the...
Okay.
Yeah, right there.
Okay. 2/3 of x to the cubed, the square root of x cubed plus c, or 2/3 of the square root of x cubed. You could either have the cube on the inside or on the outside plus c. 3 perfectly good ways, even 4 perfectly correct ways to write the answer. The book is going to only want one of them, or the web assign will. And they left it in this form here, which I thought they would. That's, to me, the easiest form. I don't like going back to radicals unless I have to. Okay? Any questions on that? Next one's another pretty easy one. The antiderivative of 2 sine x dx. Okay? Now they're going to take an extra step and pull out the 2. And you certainly can if you want to. I've got to find it. It's right there. Okay? You can take that step if you want to. I just pull it out when I'm doing the thing. Okay? I mentally pull it out. And what's the antiderivative of sine x? Anyone remember?
Cosine.
It is cosine, only it has the minus sign. Remember? Okay, minus cosine x. So this answer is minus cosine x. What else do I need? Always with indefinite integrals. Plus, oops, I left off my 2. Okay, minus 2 cosine x dx. So I don't like to use ink pen. Does everybody see that? Minus 2 cosine x plus c. Any questions? Please ask if you got it. Okay? the next one, D. The integral of 3 over x dx. Now this one, if you want to take an extra step and do it, you can. Pull out the 3, and that leaves you 3 times the integral of 1 over x dx. Does anyone remember what the antiderivative of 1 over x dx is? I'm going to go up back a slide.
Is it 0? No.
Say again? There it is.
Is it L and X?
L and X. You're absolutely correct. Okay. All right. So that's going to be 3 times the log, but remember, you have to put absolute value of x plus c. And again, that is a very straightforward way. The book takes a couple steps to get there. It's perfectly fine to take as many steps as you want, but 3 times the log absolute value x plus c. Okay? And please take all the steps you need so you understand what you're doing. That's the important thing. All right, now, as I said before, later on in the course and later courses, sometimes you express that as the log of c. That way you can use rules of logarithms to combine those terms and get it down to one term. There's not a reason to do it now, but I'm going to show you what that does for you. If rather than c, because all it is a constant, right? And if c is a constant, log c is a constant. So if you had written that actually not as c, but as 3 times the log of absolute value x plus the log of c, ln c. Now because you have log of the sum of 2 logs, okay, this is going to take a little bit of effort here. You have to remember the rules for logarithms. A constant times a log is the same as the log, and you move that constant to an exponent. So that would be the same as the log of absolute value x cubed plus the log of c. But now that you got the sum of 2 log forms, you could write that as the log of c times the absolute value of x cubed. Okay? Now, that's a different c from the one we originally had. Don't worry about this now, but I'm just showing you went from a 2-term solution by writing that as log c rather than c, and then moving the coefficient, I can't see where it is, there it is, this 3 here, up to be the exponent here, log of absolute value of x cubed plus log of c, then multiply, because the log of a product is the sum of the logs. So that for the sum of 2 logs is the log of the product, c times the absolute value. Now, there's yet another way to write that, as if you didn't have enough ways already, log of absolute, well, c times the absolute value of x cubed. Oops. Okay. You could put the x cubed all in the absolute value sign, because if x is negative, x cubed is also going to be negative. So you could either have the cubed on the outside or the cubed on the inside. It doesn't really matter. You're taking the positive, okay? And so there's how many different ways to write a correct answer. And yet, WebAssign is only going to look for one of them. Tell you the others are wrong. Okay, so that was all of example 3. 4 parts. They, by the way, used the first answer we gave, 3 times log absolute value x plus c. All right, let's do example 4. The antiderivative of dx. Okay, that should be pretty straightforward. Let me find where it is. Is that it right there? Yeah, right there. The integral antiderivative of dx. Guess what that is? Integral undoes derivative or differential. So that just leaves you x. This undoes that. That would undo this. That just leaves you x. So that's equal to x. But of course, with any antiderivative, you have to add a plus c. So not just x, but x plus c. Let's see if I can find it now. I'm reading through the paper backwards, and I can't see it. Is it somewhere on the screen there? Is this it right here? No. Yeah, that's it. Right there. Any questions on that? Okay. X plus C. The B part of this one is the integral, or antiderivative, of x plus 2 dx. So here's the one we're doing now. Okay. Now, there's two ways you can approach this. You can break it into two integrals, the integral of x dx plus the integral of 2 dx. Okay? That's perfectly fine. That's how the book does it. But also, you can just take the integral one term at a time. What's the antiderivative of x? Well, the exponent for x is 1, so you increase it by 1, making it x squared. Divide by that new thing, so it's x squared over 2, plus the exponent for your x in 2. Of course, that's 2 to the 0th power, because you don't have an x there, so x to the 0th power is 1. Increase the 0 by 1, and you get x. So that would be 2x, and then finally you do a plus c. So that's one way you can do it just from here. Antiderivative of x is x squared over 2. Remember, increase the power by 1, divide by that new power. The power here is x to the 0th. Okay? Increase that power by 1, you get x to the 1. Divide by 1, and you get 1. So you got 2x, and then you have your constant of integration plus c. Does that make sense? Or you can split it and say the integral of x dx plus the integral of 2 dx, and then that 2 dx, we call it the 2 times the integral of dx, and then it goes right back. So take as many steps as you need that you guarantee you understand what you're doing. Okay? Does that make sense? Now, let's jump to a biggie here and see if we can do it. The integral of 3x to the 4th minus 5x squared plus x dx. Now, if I'm going too fast on this, slow me down. But what you do here, increase the 4 to a 5, divide by 5. That's going to be 3/5 x to the 5th. Increase the 2 by 1, that makes it a 3, divide by the 3, plus 5/3 x cubed. And this is just an x if I can read it right. Increase that by 1, that's a 2, divide by the 2, and that would give you an x squared over 2 plus c. So, saying what I just said, that would be 3x to the 5th over 5 minus 5x cubed over 3 plus x squared over 2 plus c. Now that's one way to write the answer. It may not be the way they did, but that is one way to write the answer. Okay? If you wanted to at least common denominators, you certainly could do that. Who would care? Who would want to? Okay? So, let's see how they left it. They wrote it slightly differently, which is what I would have done. 3/5 x 5th minus 5/3 x cubed plus 1/2 x squared plus c. That's how they finally wrote the answer. Okay, I know some folks are leaving because it is time. We did finish example 4 for C. We'll begin next time with example 5. Are there any questions before we depart? So we'll begin next time at on page 288. If you've got this book, or even if you don't, we're still starting there. Top of the page, example 5. Let's go to the homework exercises at the end of the section. And folks, even if you don't have this book, you can go to calcchat.com. Do you see that written at the top in the red line? And you can see the odd number exercises there. So don't look at the answers. See if you can work them out. Or use some examples from your own book and look at the back of the book or whatever. But homework exercises here, I would say do number 5. Do either, and 5 is at calcchat.com. Do either 7 or 9. 7, they're both at calcchat.com. 7's at calcview.com. Now, if you happen to have this book, you see that QR code. If you got a smartphone, you can go straight to the QR code and do it on your smartphone, and you can see it on your smartphone. You don't have to go to a website, okay? It takes you to a website. Then do either 11 or 13. They're both at CalcChat. 13's at CalcView. Do any of the odds 15 through 35. Now that may be a little bit beyond what we've done. I think you can do all that based on what we did. Any of the odds 15 through 35, they're all at CalcChat. 15's at CalcView. And we'll hold off and do the rest of those next time. Any questions?
What page did you say again?
That's in your text on page 291. We finished 287 in the text. We'll start on 288 next time. All right. Good deal. Any other questions? Excellent. All right. Then we'll see you on Monday. Have a good weekend. Boy, one class in 2 weeks, and then we start another one. Starting next week, 2 classes a week from then on until 4th of July, okay? All right. I'm going to stop the sharing. I'm going to end the recording. And we'll see you on Monday. Good deal. Okay. Oh. Okay, I'll be right back. All right. Sorry that I'm a little late. My last class ends 5 minutes before this one begins, and I didn't have any time to go to the restroom, so I took a quick bladder break. Sorry about that. Today's the 27th, is it? Let me see, it's on my watch. Yeah, 27th. All right, let's see who's here. One person's waiting. Let me get them in. Well, I'm going to try to get them in. Here we go. All right. I've got Harry Seawright here. Okay. I've got Jacob Sr. Is that right? Let's see. Maybe his last name's, boy. Jacob Sr. Box Fade Theo Face Fix It Felix. Who in the world is that? Does anyone know who JS is? Jacob Sr. Box Fade Theo Face something another. I see your microphone's on, but I can't hear anything. Could you let me know? Is that Jacob Walker? Is Jacob Walker here? Okay, has someone got a TV on in the background? Is that Jacob Sr. Box Fade Theo Face Fix It? Is Felix something another? It's what? Who is that, please? I'm sorry? Who is this speaking? Whose handle here is Jacob Sr. Box Fade Theo Face Fix It Felix? Okay, who is this? Okay, Jacob Walker, is that who you said? Okay, excellent. It's only Jacob I saw out of all those names on there. It's the only one that matched. Okay, Thomas Habrowski. Okay. I believe I've had you in class before, haven't I? Okay. What do you go by, Thomas or what? I don't remember. Thomas, okay. And Jacob, do you go by Jacob? Jacob. Okay. You go by Jacob? Okay. And Harry Seawright, what do you go by? Say again? Harry? Okay, I'll tell you anything you want me to. Maybe some things you don't. Okay, Harry? All right. Let me get Susan in, whoever Susan is. Okay? Let me go down some more. Okay? I've got Capri here. Do you pronounce the R? I don't remember. Capri? Okay, that's what I was thinking it was. Okay, so we'll leave off the R. Capri. Okay? And you go by that. All right, let's see who else. Susan. Let's see if I can find the Susan here. So far, I'm not seeing the Susan. Who is Susan? Susan, can you let me know? Oh, wait, she's gone. How about James Roy? Okay, let me see if I can find you. I can't find you either. Have you just recently added the course? Okay, what is your last name? Roy, R-O-Y? I'm sorry? Oh, got it. Okay, it's James Roy Riggins. Okay, and what do you go by? You go by James Roy, or what? Roy, okay, gotcha. Okay. I didn't see Wigginton on there. Okay, got it. So I've got Capri here, Thomas here, Cormisha. Let me find Cormisha. There you are. Cormisha Smiley, right? You go by Cormisha? Yeah, I thought so. Okay. And David Whitlock. What do you go by? David? David's fine. Okay, I'll call you David's fine. No, I'm just kidding. Okay. David, Thomas, Capri, Cormisha, Harry. Let me go on down. I can only show so many at a time. Okay, Jacob Walker, I got you. All right, your name's much shorter now. Here's Nakaya. Oh, wait. Valerie's trying to get in. So let me get Valerie in here. There you are. Okay, Valerie, you hear me yet? No, not yet. And what do you go by? You do go by Valerie. Okay, gotcha. Okay. I can only see so many names at a time. So what I've got is Thomas, Capri, Kermisha, Harry, Jacob. How about Nakaya Conwell? Okay, and what do you go by? Okay, I even came close to pronouncing it right, huh? Amazing. Okay. All right, so I've got Thomas, Capri, Cormisha, Harry, Jacob, Nakaya. Let me go on down the list here. Parisha, is that correct? Yes. I pronounced it correctly? Okay, and is that what you go by? Okay, got it. All right, let's see who else now. I've got Cormisha, David, Harry, Jacob, Nakaya, Parisha, Roy, Valerie, Denise Wilson. I got you as Valerie. Got it. Okay. And I think that's all. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And it shows, oh, I'm missing somebody. Okay. I've got Valerie, Roy, Parisha, Nakaya, Jacob, Harry, David, Cormisha, Capri, Thomas. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I must have forgotten to mark somebody. Oh, Cormisha, I didn't mark you. There you go. Okay, I circled your name but didn't mark you present. Got it. All right, so good showing. Got a few people out still. Now, once we get going, it's going to be hard for me to see and keep up with people coming in. So if you see someone trying to come in and you don't hear me acknowledge it, please say something and let me get them in the class. Okay, because I have to give them permission. They want us to do that to keep all those people who are wanting to get the class for free. You know, this is really popular. Okay. All right. I'm sort of kidding. So let's go to share the screen and, oh, wait, I am so sorry.